Hello everyone. Today our topic is Grignard reagent. It is an important reagent in organic chemistry used for the formation of wide range of compounds. Its formula is RMGX. R here is a alkyl or aryl part. Alkyl means carbon chain. Like suppose we have one carbon, it is methyl, two carbons, ethyl, three carbons in a straight line, then it is propyl, sec or isopropyl. In a cyclic form, suppose we have. So we can also take cyclohexyl. Aryl means a phenyl ring. So we can also form Grignard reagent with the help of a phenyl ring. This is phenyl, or you can say aryl part. Next component of the Grignard reagent is Mg. Mg is a symbol for magnesium, which is metallic in nature and it is divalent. X component here is a halide part, halogen. Halogens are univalent in nature. So usually we take chloride, bromide, iodide here. So finally, what we have concluded from this formula, RMGX, magnesium is divalent, X is univalent. So this R component here is univalent in nature. So overall, the compound becomes electrically neutral. Grignard reagent is an example of organometallic compound. Organic component here is a haloalkane part, Rx, and metallic component is magnesium. So a reaction of haloalkane with magnesium metal is known as a metallation reaction. In a metallation reaction, magnesium metal is introduced in an organic molecule. So here our reactants are haloalkane and magnesium, which react with each other in a presence of reagent, solvent, you can say dry ether. Dry ether is it acts as an solvent here, a Lewis base. Oxygen of this dry ether is helpful to stabilize magnesium. So in this reaction, Rx react with magnesium in presence of dry ether to form a compound RMGX, which is a Grignard reagent. This Grignard reagent is also known as R means alkyl, Mg is magnesium, and X is halide. So other name of Grignard reagent is alkyl magnesium halide. This Grignard reagent, as it is obtained by a combination of organic and metallic component, it is unstable, highly reactive in nature, and is a rich source of carbanion. What is a carbanion? a negatively charged carbon. Why it is a rich source of carbanion? Because magnesium is divalent, and with respect to magnesium as a whole, this compound is electrically neutral, and we know that halide is univalent. So with respect to this magnesium, carbon is univalent anion here, R minus a carb anion, that is behave like a nucleophile. So Grignard reagent is a rich source of carb anion. As Grignard reagent is a rich source of carb anion, so it has great affinity for H plus ion. So any of the compound which is protic in nature, which has ionizable hydrogens, like we have HCl, we have water, ROH, RCOH, or we can also take ammonia and its derivative like NH3 we can also take here, which dissociate as H plus and NH2 minus. So any of the compound which is a rich source, which is a source of H plus ion, so this Grignard reagent react with that compound to form hydrocarbon. So this is a hydrocarbon. A most important question usually asked from this part, reasoning, R means reasoning question. Why Grignard reagent should be prepared under anhydrous condition? Why Grignard reagent should be prepared under anhydrous condition? Because being unstable in nature and a rich source of carbon ion, so in the presence of H plus ion, it forms hydrocarbon. Conversion tip: if you wish to convert haloalkane to alkane, then always do this with the help of a Grignard reagent, as Grignard reagent is used to convert haloalkane to alkane. For example, suppose we have N-propyl, which we have to convert in a propane. The first step of the conversion is to draw the structure of reactant and product like N-propyl bromide and propane, and then compare the structure. If you just compare the structure of reactant and product over here, you just found that word root part is same in both case. 3 carbons, 3 carbon. The only difference is this: Br of N-propyl bromide is replaced by hydrogen here. In a product side, we are having a hydrogen in place of bromine. So such types of conversions are we do with the help of Grignard reagent. First of all, we convert this in Grignard reagent. We form a Grignard reagent here with the help of magnesium and dry ether. So we have N-propyl magnesium bromide. Next step is the hydrolysis of this. So this N-propyl magnesium bromide on hydrolysis gives propane. Next conversion is the benzyl chloride changes to toluene, which is a methyl benzene. Benzyl chloride, and we simply compare the structure of reactant and product, then here Cl of benzyl chloride is replaced by hydrogen. In reactant side we are having a Cl, whereas in a product side we have a hydrogen here. So what we do again, convert this benzyl chloride into Grignard reagent, which is an organometallic compound with the help of magnesium and dry ether. So we have C6H5, CH2 benzyl, then magnesium, and then chloride we have. And this benzyl magnesium chloride on hydrolysis gives methyl benzene. Let's do few filling the blanks based on Grignard reagent. Like in first we have CH3Br with Mg and dry ether, it form CH3MgBr, and this CH3MgBr methyl magnesium bromide on hydrolysis gives methane. Then next we have isopropyl iodide with magnesium and dry ether form Grignard reagent. This Grignard reagent on hydrolysis gives propane. Third example, bromobenzene with magnesium and dry ether form phenyl magnesium bromide. This phenyl magnesium bromide on hydrolysis gives benzene. Next, cyclohexyl chloride with magnesium and dry ether gives cyclohexyl magnesium chloride, which on hydrolysis forms cyclohexane. Last, bromoethane with magnesium and dry ether gives ethyl magnesium bromide. Now this ethyl magnesium bromide on reaction with D2O. D2O is basically a heavy water. D here is deuterium, gives in place of MgBr here we have D. D is the deuterium. Let's take another example in the form of a word problem, like a compound A, which is a bromo derivative having a molecular formula C4H9Br. This compound A with magnesium and dry ether forms a compound B, which is a Grignard reagent. This Grignard reagent on hydrolysis gives this compound. So hint is given over here. B on hydrolysis gives this compound. It means if it goes back, this in place of this hydrogen, what we put here? MgBr. Because B is a Grignard reagent. Now on back reaction, B gives bromoalkane. So A is a compound which is tert butyl bromide. So tert butyl bromide with magnesium and dry ether forms this compound B. B on hydrolysis gives a compound 2-methyl propane. So with the help of this prompt, we are able to recognize structure of A and B. Let's switch to next problem. Some organic compound A, in the presence of magnesium and dry ether, gives a compound Q, which is a Grignard reagent. Q, with the help of a heavy water, deuterium, gives a compound, this one. Here D is a deuterium isotope of hydrogen. So if it goes back, then Q should be in place of D, what we put here? MgBr. And this MgBr, this Grignard, is obtained from this compound. You can call it isobutane or 2-methyl propane.